Hi all. Let's see the next topic of Unit 1, computer registers. Looking at the contents, what is the definition of a computer register? And let's see what are the different types of registers present in a computer. So computer registers, a register in a computer, it is basically a temporary storage location where we can store our data as well as the instructions. And these are used by the CPU or a central processing unit for quick processing. So the main use of a register in a computer is for to be used by the CPU as well as the so that it can be processed or accessed quickly by the CPU. And registers are very critical components of a computer memory because they allow efficient access as well as manipulation of information. So the registers which are used by the CPU, we call them as the processor registers or simply the registers. So a processor or a computer register, it can hold an instruction or it can hold an address of a memory location or it can hold a data, which can be a sequence of bits or individual characters. So computer registers, there are different types of registers present in the computer where some registers holds an address of an instruction, where some registers holds a data or a bit sequence, where some registers holds an instruction itself. So let us look at the register and memory configuration of a basic computer. So this is a basic computer which contains a list of registers as well as a memory unit of a computer. So if you look at this diagram, there is a memory unit. So this is a memory of a computer and it is capable of storing 4096 words. So, and each word is capable of storing 16 bits of information. So this memory, it has a capacity of 4096 words where each word has a capacity of storing 16 bits of information. So apart from the memory unit of a computer, it also contains certain registers which are present in the computer. So let's see in detail about each and every register. Coming to the first one, the first register is called as a program counter. So if you look at the registers here, uh, there is a numbering which is given for each and every register. It starts from 0 and ends with some number. So if you look at this particular register PC program counter, it starts at the address location 0. So the first bit of the particular register starts at 0th bit and it ends at the 11th bit. So the total capacity of this particular register is 12 bit. So it is a 12 bit register starting from bit 0 to bit 11. Similarly, this register is a 16-bit register, the IR. It starts with 0 to 15. The numbering of bits starts from the leftmost bit towards the right. So it starts from 0 to 15. So if you look at this register, it is an 8-bit register starting with the numbering from 0 to 7. So similarly, all the registers, they have certain capacity. Some are like 12-bit registers, some are 16-bit registers, where some registers are only 8-bit registers. It depends upon the register. So if you look at this, there are some list of registers here. PC stands for program counter, AR stands for address register, IR stands for instruction register, TR stands for temporary register, DR stands for data register, and AC stands for accumulator. And coming to this 8-bit registers, out R and in par. Out R refers to output register and in par registers to input register. Coming to the first register, the program counter. The program counter, it points to the address of the next instruction that has to be executed by the CPU. Say for example, I have a program which contains say 1 to 10 instructions. So on 10 instructions. And CPU is initially executing the instruction 2. So the program counter points to the address of the next instructions that is present in the memory location PC. So the program counter points to the instruction 3 and it points to the address where that particular instruction is present in the memory. So that is called as a program counter. Next, coming to the next register, AR, address register. So address register, so next is an address register. Address register contains the address of the instruction that needs to be executed. So it is a address register which stores the address of the particular instruction. So it is a 12-bit register. Next, coming to the instruction register. So instruction register is a 16-bit register which stores the instruction that has to be executed by the CPU. So if the CPU is executing an instruction 2, the instruction register contains the instruction which is stored in the instruction register. Okay. Next register is the temporary register. So temporary register is a 16-bit register. It is a data register which stores the data. So it stores the data of the particular temporary result. Say for example, if I'm adding two numbers, two operands, say A and B. If I have one more operand C, that is stored in a temporary register. So next register is DR, the data register. So if you take the same example of adding two operands A and B, the first operand A will be stored in the data register, whereas the second operand B will be stored in the accumulator. So uh, they are stored at a memory locations. So whenever the CPU wants to execute that particular instruction, say add A comma B, the operands A and B has to be bought from the memory into the registers, and then they need to be executed so that CPU can easily, fastly, quickly access the particular data if they are present in the registers. So the particular operand A will be, one operand will be stored in the data register, where the second operand will be stored in the accumulator. And these two registers are given as an input to an ALU, arithmetical logic unit, which performs an addition of the two contents of two registers, and the result is again stored in the accumulator before storing the result back into the memory location. So these two, data register and accumulator, these two are also a data. They stores the operands or the data which are a 16-bit register. Say for example, if I'm having three operands, add A comma B comma C. Then apart from these two registers, data register and accumulator, which are used to store the operand, I can also make use of a temporary register TR to store the operands. So this is a use of these three registers. So PC program counter stores the address, it points to the address of the next instruction. Where address register contains the address of the particular instruction. These two stores the address. Where instruction register stores the instruction, which is a 16-bit instruction. Temporary register is used to store the temporary results or temporary operands, anything. And coming to the next two registers, output register and input register. So the input register is used to take the input from the user. So once you give an input, say you want to give an input of an operand A. So the particular input will be taken through the keyboard by the user, and it is stored in the input register before it is being stored in the memory unit of a computer. Similarly, the output register, once the computation has been performed and say the addition of two numbers has been performed, and the result which is available in the accumulator is stored into the memory location. So from the memory location, that has to be given is it as an output to the user. So before giving it as an output to the user, you cannot directly give it. It has to be the output register takes the result from the memory location and give it as an output to the user. So this is a use of an input register and output register. So they can take the input or output, they can give an output only 8 bits at a time. Since the capacity of the registers are only 8-bit registers. So if you look at this, the data register DR, it is a 16-bit register which is used to hold the memory operand which is stored in the memory location. And address register, AR is a 12-bit register which holds the address for the memory. And accumulator, which is a 16-bit register, it is used by the, we call it as a processor register because it is used by the CPU during the execution of an instruction. And instruction register IR is also a 16-bit register which holds the instruction. And program counter PC is a 12-bit register. It holds the address of the particular instruction, that is address of the instruction. Next, coming to temporary register, it is also a 16-bit register. It is used to hold the temporary data. Next, the input register. These input and output are 8-bit registers, and the input register carries the input characters, where an output register stores the output characters that has to be given to the user. So the memory unit has a capacity of 4096 words. Each word contains 16 bit. The data register contains 16 bit, which holds the operand read from the memory location. So the address register is also called, you can also call the address register as a memory address register, which is a 12-bit register which holds the address of the memory location. And the program counter is a 12-bit register which holds the address of the next instruction that has to be read from the memory after the current instruction has been executed by the CPU. Next, the accumulator AC is a general purpose register, and the instruction read from the memory is placed into the instruction register. So once the CPU wants to start executing an instruction, it has to be bought from the memory and kept it into a register called instruction register. The temporary register is used for holding the temporary data during the processing by the CPU. And the input register holds the input characters given by the user. And the output register holds the output after processing the input data. Thank you.